Okay, this is part 4 of this semester's exam. You've got 4 metal plates with some charges on each one, and they're initially isolated. You're supposed to calculate the electric field in region 2, so in this region here, and the electric potential difference between plate C and plate B. So you have 4 plates. The electric field due to each charged plate is sigma over 2 epsilon naught, or charge per area over 2 epsilon naught. And so the field in the center is going to be the fields due to each of these. So you have the field, let's add these up. Each of them has this 1 over 2a epsilon naught. So we can pull that out and then add up just the charges. So the electric field will point away from this one, and so let's find the field to the right. The electric field points away from this, so it's 5 nanocoulombs. It'll point towards this one, so subtract 2 nanocoulombs. It'll point towards this one, so we'll add 4 nanocoulombs, and it'll point away from this one to the left, so we'll subtract 1 nanocoulomb. And so this is 6 nanocoulombs over 2a epsilon naught, and if you plug that in, you get 8471 volts per meter, and that's to the right. For the potential difference between C and B is the work done to go to move a charge from B to C. So if you move a positive charge from there, the work done will be the electric field times the distance. So that is this 8471 volts per meter times the distance is 0.03 meters, and that comes out to 254.13 joules, or sorry, volts is the potential difference. Okay, so here's part B. It says now plates B and C are connected by a wire as shown. What are the new charges QA, B, C, and D in units of nanocoulombs? Okay, so you connect plates B and C. If they're connected by a wire, then these plates B through the wire to plate C is all one conductor, and so it's all going to be held at one potential. So the potential difference between these 2 plates now is 0, which means that basically because of what we did in this part, that the electric field inside between here and here has to be 0 now. So charge will rearrange itself for these 2 plates to be at the same potential and to have 0 field in here. So if we want 0 field in here, we have to find the charges on these 2 plates that will cancel the fields in this region on plates A and D. So the electric field now is this 1 over 2a epsilon naught. We're still going to point away from plate A, so 5 nanocoulombs to the right. We'll point, these are both still negatively charged, so we'll point towards this one, so minus QB. We'll point towards this one, so plus QC, and this over here will point away from this one still, so minus 1 nanocoulomb here. And this all has to add up to 0 because we want 0 potential difference between these 2 plates, so